Welcome to today's deep dive. We are really thrilled to have you here with us.
Absolutely. It's great to dive into this.
Yeah. Today, we are wading into a topic that is just dominating. Every single leadership meeting, industry conference, vendor pitch, you name it.
You really can't escape it right now.
You can't. We're talking about artificial intelligence in healthcare administration. Because as administrators, you're just getting bombarded with AI marketing fluff right now.
Oh, constantly.
Every new software update claims to be AI-driven, and it can feel, honestly, impossible to separate the actual utility from the overwhelming noise.
Right, the signal from the noise.
Exactly. So our mission today, looking at our source guide, Demystifying AI for Healthcare Administrators, is to strip away that marketing veneer. We want to look under the hood of these tools.
Because you don't need a computer science degree for this.
Right. You just need to be willing to learn. We're going to build a foundational, working understanding of what AI actually is, and just as importantly, what it absolutely is not.
It's such a critical time to build that literacy, really. The terminology around these tools is thrown around so loosely in the corporate world.
It's everywhere.
It is. And it creates a very dangerous blind spot for decision makers. Taking the time to understand the basic mechanics of how these systems function, that's one of the most vital professional steps you can take to protect your organization and, optimize your workflows.
So to kick things off, I want you to picture this scenario. You're staring down a deadline for a major department policy update.
We've all been there.
Right. You decide to try out one of the highly advanced AI tools everyone is talking about. You type in your prompt, and within seconds, it generates an incredibly professional, beautifully articulated, authoritative-sounding policy memo.
It feels like magic at first.
You're amazed. But then, as you read closer, you notice a citation to a major medical journal to back up a specific protocol.
Ah, here it comes.
You go to look up that research paper,
Yeah.
and you discover it doesn't exist.
It's completely fabricated.
The AI confidently invented a completely fake study. Imaginary authors, realistic-sounding title, everything. How can a system be so brilliantly articulate and so factually wrong at the exact same time?
It's a jarring experience, especially the first time it happens to you. You're looking at a document that reads like it was written by a seasoned healthcare executive,
Right.
yet it contains a fabrication that would get a first-year grad student expelled.
Exactly.
But by the end of this deep dive, that exact bizarre scenario will make perfect sense. The mental shift we have to make today, the real aha moment, is to completely stop anthropomorphizing artificial intelligence.
You have to stop treating it like a person.
Yes. We have to stop thinking of it as a human brain and start understanding it as a massive, highly sophisticated, probabilistic pattern-matching machine.
Okay, let's unpack this, because the word AI is applied to literally everything now. From the voice assistant setting a timer on my phone to the predictive staffing models we use in the emergency department.
It's a massive umbrella.
It is. So how do we actually define artificial intelligence when the category is that broad?
Well, at its most foundational level, artificial intelligence is simply a broad category of computer systems designed to perform tasks that typically require human intelligence.
Okay.
So that includes recognizing visual patterns, understanding spoken or written language, making complex decisions. The danger is treating AI as one single monolithic technology.
Because it's not.
It's not a monolith at all. A system designed to read a chest x-ray shares almost no underlying architecture with the chatbot you use to draft an email. Each system is built differently, trained differently, and suited for entirely different tasks.
Which brings us to a specific branch of AI that is reshaping administrative workflows right now, machine learning.
Yes, machine learning is key here.
If I'm using my hospital's legacy scheduling software, a human programmer wrote out explicit rules for how that software operates, right? Like, if X happens, do Y. How does machine learning break away from that traditional programming?
Traditional programming is exactly as you described. Explicit, step-by-step instructions. Machine learning abandons that approach entirely.
Oh, completely.
Completely. Instead of writing rules, developers feed the system staggering volumes of data, and the system learns to identify patterns within that data entirely on its own.
Okay, give me an example of that.
Imagine trying to write a traditional software rule for every single way a fraudulent insurance claim might look.
That would be impossible. There are just too many variables.
Exactly. With machine learning, you don't write rules. You feed the system millions of historical claims, both legitimate and fraudulent. And over time, the system independently maps out the subtle, complex statistical features that flag a claim as suspicious.
And just so we have our terminology straight for later, I know there are different ways these machine learning systems process all that data,
Yes, there are different architectures under that machine learning umbrella. For instance, a system might build a decision tree.
which is like a flowchart.
Essentially, yes, a highly complex data-driven flowchart to sort information and arrive at a conclusion. Or it might use a neural network.
And a neural network is,
It's a far more complex system of layered statistical nodes. It's very loosely inspired by the structure of the human brain. Neural networks are incredibly powerful for tasks like image recognition or processing natural language
yeah.
because they can weigh millions of intersecting variables all at once.
That sets us up perfectly to talk about the tools that are just dominating the headlines right now. ChatGPT, Claude, Gemini,
The big ones.
the interfaces we are all experimenting with. These specific tools fall under a subcategory of machine learning called large language models, or LLMs, and they run on those complex neural networks.
That's right. A large language model is an AI system trained specifically on enormous quantities of text data.
And when we say enormous,
It challenges human comprehension.
yeah,
The training data for these models includes digitized books, millions of articles, massive scrapes of public websites, academic repositories, vast libraries of computer code.
so basically the whole internet.
Essentially, yes. They ingest a significant percentage of all recorded human communication available online.
The scale is just staggering. We are talking about models trained on hundreds of billions of words. But if an LLM isn't reading those billions of words to learn facts, and store them in a database like a digital encyclopedia, what exactly is it doing during that massive training process?
It's learning statistical relationships. As the neural network processes those hundreds of billions of words, it maps out how words, phrases, and concepts relate to one another mathematically.
Mathematically, not contextually.
Exactly. It learns that in a medical context, the word myocardial is statistically very likely to be followed by the word infarction.
Okay.
It absorbs the structural patterns of how a professional policy memo is formatted. It learns the cadence of a corporate apology or the standard structure of a peer-reviewed abstract.
So it's learning the shape of the language.
Yes, the shape. But this is the crucial distinction. It is never learning the underlying meaning of those words. It is strictly learning the statistical probability of how those words are sequenced together.
Which leads right into a trap that is so easy to fall into. We open up a chat interface, it greets us in conversational English,
Yeah.
and we immediately start treating it like a human colleague.
We project humanity onto it.
We do. We treat it like an incredibly fast intern who just happens to have read every book in the world.
And that illusion of understanding is the single biggest misconception you have to overcome. A large language model does not think. It does not reason. It does not possess an internal model of the world.
It's just processing data.
It has zero beliefs, zero intentions, and absolutely no consciousness.
So let's go back to our scenario of drafting the policy memo. I asked Claude to write a memo about a new telehealth protocol. What is actually happening under the hood when I hit enter? And I know it's not pondering the complexities of remote patient monitoring.
Not at all. It is taking your prompt and mathematically predicting the next most likely sequence of words that would satisfy that request, based on the billions of statistical relationships it mapped during training.
Wow.
It's basically the autocomplete feature on your smartphone, but scaled up to an unimaginably powerful, complex degree.
It's just autocomplete.
It's just math, predicting one word after another to generate text that statistically resembles a competent human response.
The autocomplete analogy makes so much sense, and that perfectly explains the hallucinated research paper in our memo. If it's just a hyper-advanced autocomplete, it doesn't actually know what a real medical journal is.
Exactly. What's fascinating here is that when it generated that fake citation, it wasn't lying to you.
Because lying implies intent.
Right. Lying requires an intent to deceive and an underlying knowledge of what the truth actually is. The LLM has neither.
It just saw a pattern.
Yes, it simply recognized a statistical pattern. Professional policy memos often include citations to medical journals, so it generated a string of text that perfectly matched the pattern of a citation.
It predicted a plausible-sounding title, attached it to a statistically common author name, and formatted it perfectly.
It generated the pattern of a fact without any underlying connection to reality.
Here's the mind-blowing part of this for me. Those hallucinations, those fake citations, they aren't software bugs. As administrators, we are so used to thinking that if software outputs something wrong, it's a glitch. The IT department or the developer needs to patch it.
Right, you submit a ticket.
Yeah. But these hallucinations are the system doing exactly what it was designed to do.
You're asking a pattern generation engine to act like a relational database. It's a fundamental mismatch of the technology's core architecture.
Wow.
The system is functioning perfectly. It is generating statistically probable text. The error lies in the human expecting that probabilistic text to represent absolute, verifiable truth.
And this brings us to a massive paradigm shift. If you are going to use these tools professionally, you have to understand the difference between deterministic software and probabilistic software.
It's the most important distinction you can make.
If I use my hospital's billing software or our staff scheduling application, those systems follow strict rules. If the billing system spits out an incorrect output, it's either because there's a flaw in the code written by the programmer.
Or a clerk typed the wrong billing code into the input field.
Exactly.
Those traditional systems are deterministic. They process inputs according to defined logic and explicit algorithms. If you put the exact same data into a deterministic system 1,000 times, you will get the exact same output 1,000 times.
Because they're following a track.
They do exactly what they are programmed to do, nothing more and nothing less.
But if I take a large language model and I ask it the exact same complex question with the exact same phrasing twice in a row, I might get two completely different answers.
You very likely will.
If my billing system did that, I would call the vendor and demand a refund because the software is broken. But with an LLM,
With an LLM, that variability is the defining feature. It is a direct result of its probabilistic design. Every time you submit a prompt, the system is calculating probabilities on the fly. Because there are often multiple statistically valid ways to sequence the next few words, the model can take a different textual path each time it generates a response.
think about what this means for your daily administrative workflows. Because of this probabilistic nature, LLMs are incredibly flexible and remarkably capable across a wide range of variable creative tasks.
They're amazing for that.
If you need to brainstorm agenda topics for a leadership retreat, draft a first pass in an employee newsletter, or summarize a dense 50-page regulatory update into bullet points, an LLM is a phenomenal tool.
But that same flexibility makes them highly unreliable and, frankly, dangerous for tasks requiring consistent, strictly rule-based accuracy.
Right.
You would never use a probabilistic tool to calculate employee payroll, finalize a clinical dosage, or determine patient eligibility for a specific treatment program.
No, absolutely not.
A professional who understands this distinction knows exactly when to lean on an LLM for its creative text generation and when to absolutely rely on deterministic software systems for guaranteed accuracy.
This makes me wonder about the AI we already use in hospitals every day. Because artificial intelligence isn't just ChatGPT. Healthcare administration is already deeply embedded with machine learning.
It's been there for years.
Right. We have natural language processing tools extracting data from messy clinical notes. We have predictive analytics forecasting our Friday night emergency department surges. We have automated systems reviewing prior authorizations. So how are those systems different from just opening a browser tab and asking a general LLM to do the work?
The difference comes down to purpose, validation, and guardrails. Those existing systems in your revenue cycle or your triage departments are purpose-built AI.
Purpose-built?
Yes. They were designed and trained for one highly specific, narrow task. Furthermore, they are clinically validated, they are deeply integrated into your institution's specific workflows, and crucially, they produce audible outputs.
Meaning you can check their work.
Exactly. If a predictive model flags a patient for sepsis risk, you can usually audit the data points that led to that alert.
And they operate in a heavily regulated environment. Many of those purpose-built clinical systems are subject to rigorous oversight by bodies like the FDA. They're treated as medical devices. They have strict parameters.
Contrast that with general-purpose tools like Gemini or Claude. These models are available to anyone with an internet connection.
Right.
They were built to answer questions about history, write computer code, translate languages, and write poetry. They were not built specifically for the high-stakes environment of healthcare.
No.
They lack clinical validation for medical decision-making, and they are not governed by the same strict, rigorous regulations that oversee your purpose-built integrated hospital software.
So the takeaway here is a delicate balancing act for administrators. These general-purpose LLMs are genuinely powerful. They are highly accessible and undeniably useful for reducing your administrative burden.
Absolutely.
But bringing a highly capable, probabilistic, completely unvalidated tool into a highly regulated healthcare environment introduces massive risk. You, the human administrator, have to be the guardrails.
It requires setting incredibly realistic expectations about what the technology can and cannot do. First and foremost, AI is not magic.
It is not
It
magic.
is a mathematical tool, and
Yeah.
it is highly fallible.
Let's burst a few more bubbles here, based on our source text. There's a massive misconception about data access. People assume these AI interfaces are omniscient.
You really do.
Your LLM does not have secret access to your internal organizational data. It doesn't know what the CEO said at last week's confidential board meeting because that information was not in his public training data.
Right.
Unless you explicitly provide the context in your prompt, the AI is completely blind to your internal realities.
And it is absolutely not a replacement for professional judgment. It cannot replace institutional knowledge, and it fundamentally cannot replace human accountability.
That's a huge point.
If you use an LLM to draft a flawed departmental policy and you sign off on it without verifying its claims, the accountability rests entirely on you. You cannot blame the pattern matching machine for generating the text you approved.
This raises a massive red flag regarding how we interact with vendors. AI has become the ultimate marketing buzzword. A slick sales rep comes into your office, pitches a new analytics dashboard or a patient outreach platform, and their main selling point is that it's driven by AI.
You see it everywhere.
You cannot just nod along and accept that as a feature.
No, that claim demands rigorous scrutiny. As an AI-literate administrator, it is your responsibility to interrogate that vendor.
You need a checklist of hard questions to throw right back at them.
Yeah.
And this is where our earlier definitions really pay off. You need to ask them, what exact kind of AI are you using?
Yeah.
Is this a relatively simple deterministic decision tree, or are you running a complex probabilistic neural network? What specific data was used to train this model?
Exactly. Was it trained on validated, peer-reviewed clinical data or just massive scrapes of the open internet? You must also demand evidence of validation. What concrete outcomes have actually proven that this tool works in a hospital setting similar to yours? And what specific policies govern its use, its data privacy, and its tendency to hallucinate?
You have to know.
Demanding that level of transparency is the definition of responsible AI adoption. You have to understand the underlying mechanics before you allow these systems to touch your patient's data or your organization's workflows.
We have covered a tremendous amount of ground today, so let's synthesize this. Artificial intelligence is not one tool. It is a massive category of technologies. The tools currently making headlines are large language models.
The LLMs.
Right. They are incredibly powerful probabilistic text generators powered by complex neural networks and trained on hundreds of billions of words. They do not think, they do not reason, and they do not understand meaning.
They are just guessing statistical patterns.
They operate like a highly advanced autocomplete. This makes them wonderfully flexible for creative and variable administrative tasks, but highly dangerous if you rely on them as absolute factual databases.
And the trajectory of AI adoption in healthcare is rapidly accelerating. These tools are not a passing fad. They are already embedded in the software your organization uses every day.
It's already here.
It is. The choice facing leadership today is no longer whether or not you will engage with AI. The only choice left is how you will use it. Will you deploy it thoughtfully, critically, and in a manner that respects its limitations and strictly adheres to your professional and ethical obligations?
Because understanding this technology is no longer optional. It is a foundational professional competency. Which leaves us with one final provocative thought for you to mull over as you head into your next leadership meeting.
Let's hear it.
Utilizing these systems is becoming mandatory for the future of efficient healthcare operations. Yet, as we've established today, these systems cannot reason, they guarantee zero accuracy, and they can never absorb human accountability.
No, they can't.
So, as healthcare administration accelerates headfirst into this new technological era, how will the very definition of professional judgment have to evolve when one of your most heavily relied upon administrative tools is fundamentally incapable of understanding the work it is actually doing?
It is a fascinating paradox to navigate.
It really is. Thank you so much for joining us on this deep dive. Keep questioning, keep learning, and we will catch you next time.